Welcome student. Today we will discuss plate tectonic theory. Very important topics for UPSC and PCS optional and also important for GS paper. Getting well now? As far as the question of plate tectonic theory is concerned, you see plate tectonic theory getting well now? So you actually plate tectonic theory is considered most effective theory to explain second order landform. It means particularly you can apply plate tectonic theory to explain the origin of tertiary fold mountain, volcanic eruption, earthquake, tsunami, also origin of Iceland, arc and festoon, etc. Okay. Again, oceanic trench, oceanic deep can be explained on the basis of plate tectonic theory. So that's why it is considered as most effective theory. Getting well now? Now you see, as far as the question of plate tectonic theory is concerned, there are three terms. One is plate, second is tectonic, and third one is theory. Getting well now? Yesterday we had discussed about continental drift theory. Continental drift theory explains the fragmentation of Pangea, you know. Okay. Explain the fragmentation of Pangea. This was the landmass, united landmass prior to Carboniferous period. Getting well? And you see, continental drift theory explain the fragmentation of Pangea, and also you see, continental drift theory explain the origin of first order landform, including continent and the oceanic area. Getting well? Then fragmented part of Pangea was referred to as plate by Tujo-Wilson. Tujo-Wilson was the geographer who used the term plate to identify the fragmented part of Pangea. Getting well? What is the meaning of plate? It is clear. The term plate refers to the fragmented part of Pangea, and it was this term was coined by Tujo-Wilson. Getting well? Again, you see, as far as the question of tectonic, we are clear about plate. Second term is tectonic. So the term tectonic was derived from G. Tecton, on the name of important geographer G. Tecton, who first noticed the movement of the interior part of the earth. That's why the term tectonic means movement. Technically, all type of movement of the earth interior is referred to as tectonic. Getting well? The plate term was coined by Tujo-Wilson. The term tectonic derived from the term G. Tecton, who particularly first noticed the movement of the rock in the interior part of the earth. Okay? And you see, Morgan was the first geographer, Morgan, who first used the term plate tectonic combinedly. It is clear? Plate tectonic term was first used by Morgan. Getting well now? Morgan was important geographer who used the term plate tectonic combinedly for the first time, and plate tectonic theory was propounded by H. Hess, Harry Hess. Getting well? What is the introduction of this theory? It is clear now? I said that plate tectonic theory is considered most effective theory to explain the second order landform. Right? It is the combination of three terms, plate, tectonic, and theory. Plate refers to the fragmented part of the plate. Tectonic means movement of the rock in the earth interior. Plate tectonic was first combinedly used by Morgan, and plate tectonic theory was propounded by H. Hess. Getting well now? Now see, and it is most effective theory to explain the second order landform, including mountain, including particularly you see volcanic eruption can be explained, earthquake can be explained. Again, you see tectonic activity like tsunami, right, can better be explained on the basis of plate tectonic theory. Getting well now? Now see, as far as the question of plate tectonic theory is concerned, so plate tectonic theory explains the relative movement of the plate. Getting well? What is the basic idea or what is basic particularly ideology behind plate tectonic theory? So plate tectonic theory explains the relative movement of the plate, not individual movement to be noted, right? Explain the relative movement of the plate, relative movement. Getting well? Relative movement of the plate. Getting well? Now see, as far as the question of plate tectonic theory is concerned, you see, according to size, there are two types of plate. We are discussing about plate. So according to size, size, there are two types of plate. One is measure plate, which are larger in size, and second is minor plate, okay, which are smaller in size. Getting well now? So particularly according to size, there are two types of plate. One is measure plate and second is minor plate. As far as the question of number of plate as a result of fragmentation of Pangea is concerned, this issue remain controversial, okay, because different geographers propounded different particularly opinion about the number of plate, but most effective hypothesis was given by Lipison. He said that as a result of fragmentation of Pangea, 6 major and more than 20 minor plates originated. 6 major and more than 20 minor plates originated. It is clear now? Among the major plates are, you can say, see, Eurasian plate is the major plate, Indian Australian plate is the major plate, African plate is the major plate, American plate is the major plate, again Pacific plate is major plate, and Antarctica plate is the major plate. It means particularly, and you see, example of the minor plates are Nazca plate, Caucasus plate, Japanese plate, right, Philippines plate. They are the example of minor plate, okay. So it is clear now? According to size, there are two types of plate. One is major and second is minor. Getting well? You see, I will draw the figure, right? Later I will probably draw the figure indicating the plates. Getting well? Again, you see, according to nature, there are three types of plate. One is continental plate. Second is oceanic plate, and third one is partially continental and partially oceanic plate. Getting well? So according to nature, there are three types of plate: continental plate, oceanic plate, and partially continental and partially oceanic plate. Getting well? Actually, you see, continental plates are made up of sial. You know, is made up of sial. Okay. Generally, you know, and it is acidic in character. But this is not according to plate tectonic theory, you should know, right? Actually, plate tectonic theory use different term, not sial, right? Lithosphere and astherosphere was used, okay? So the upper crustal part, you can say that the upper part of the continent is made up, is acidic in character. Again, the upper part of the oceanic plate is basic in character, okay? Continental plates are acidic, oceanic plate are basic, but if particularly the plate is partially continental and partially oceanic, then this part will be continental and acidic in character, and this part will be basic in character. Getting well? As for example, you see, Eurasian plate is the example of continental plate. It means it is acidic in character, okay? Pacific plate is the example of oceanic plate, and hence it is basic in character. And you see, as far as the question of African plate is concerned, so African plate extend along with Africa, right? Eastern part of Atlantic Ocean is also located on African plate. Getting well? So African continent is acidic in character, but the part of African plate, which exists in the eastern part of the Atlantic Ocean, is basic in character. Getting well? So according to size, we have two types of plate: major plate and minor plate. According to nature, we have three types of plate: continental plate, oceanic plate, partially continental, and partially oceanic plate. Getting well? Third aspect, you see, according to relative movement, According to relative movement, there are three type of plate. Getting well now? According to size, we have two plate, major and minor. Example of major plates are Eurasian plate, Indian Austral plate, African plate. Getting well now? Okay. African plate, etc. It is clear. And now, according to relative movement, according to relative movement, you must know one thing. Plate tectonic theory has nothing to do with the individual movement of the plate. Getting well now? Plate tectonic theory has nothing to do with the individual movement of the plate. It is associated with the relative movement of the plate. Okay? It is associated with the relative movement of the plate. Getting well? So, according to relative movement, there are three type of plate. You see, if the two plates move towards each other, it is referred to as convergent plate. Getting well now? This is the example of convergent plate. Getting well? Right? If the movement of the two plates are towards each other, it is referred to as convergent plate. If the two plates move in opposite direction, getting well now? Right? It is referred to as divergent plate. Divergent plate. Getting well now? But if the plate laterally move either in the same direction or in opposite direction, getting well now? So this type of plate is referred to as conservative plate. Getting well? So according to relative movement, we have three type of plate. One is convergent plate, second is divergent plate, and third one is conservative plate. Getting well now? You see, as far as the question of convergent plate is concerned, when the two plates will collide, one plate will be subducted, and when it will enter in the interior part of the earth, you know that very high temperature condition prevail in the interior part of the earth. That's why the plate will melt to form magma, okay, and hence there will be destruction of the plate. That's why convergent plate is also referred to as destructive plate. What is the meaning of destructive plate? It is clear now? Convergent plate is the example of destructive plate. Getting well? On the other hand, when two plates move in opposite direction, in this case there occur reduction in the pressure in the interior part of the earth, and hence rock melt to form magma and come along with the fissure created due to divergence of the plate, and first particularly it solidify to form the new oceanic crust. That's why divergent plate is referred to as constructive plate. Okay? It is clear that convergent plate is destructive plate, divergent plate is constructive plate. Okay? But if the plate will move laterally, it means particularly there are no changes, neither destruction occur nor formation occur. That's why such type of laterally moving plates are referred to as conservative plate. So according to relative movement, we have three type of plate: convergent, divergent, and particularly conservative plate. Getting well now? But one important point, you see, as far as the question of convergent and divergent plate or conservative plate are concerned, so you must particularly keep in mind one thing. Suppose this is one plate, getting well now, and this is another plate, getting well, okay? So actually the plate, the marginal part of the plate is referred to as plate margin. Marginal part of the plate is referred to as plate margin, getting well now? This is also plate margin and this is also plate margin. But the intervening zone between the two plates is referred to as plate boundary. What is the basic difference between plate margin and plate boundary? Getting well now? When a plate boundary is the intervening zone between the two plates, and plate margin is the edge of the plate, marginal part of the plate. Getting well now? Right? So plate margin is considered as the weakest part of the Earth's surface, and more than 85% of the total tectonic phenomena remain associated with the marginal part of the plate. Getting well? one important point, you see, if I am saying that this is A plate and this is B plate, and these are moving towards in opposite direction or towards each other, suppose, right, it is moving in this direction and it is moving in this direction, then it is referred to as convergent plate, okay? But suppose if there is third plate C here and it is moving in this direction, then A and C is divergent in character. That's why it is better to refer that this is convergent plate margin, this is divergent plate margin. Getting well now? Divergent plate margin. As for example, you see, right, actually here this is American plate, okay, American plate, getting well now? An American plate, and this is Pacific plate, you know, Pacific plate, and this part is African plate, African plate. So African plate is moving in opposite direction. Getting well? Because you see, African plate extend up to the eastern part of the Atlantic Ocean, and American plate extend up to western part of Atlantic Ocean. Getting well? So that's why African and American plate are referred to as convergent, divergent plate. But here particularly, this is Pacific plate now. So Pacific plate is the example of convergent plate. Getting well? So this is American plate and this is Pacific plate. So their margin are the example of convergent plate margin. But on the other hand, this eastern margin of the American plate is divergent with the African plate. Getting well now? So that's why it is better to refer the plate, convergent. It is better to refer plate margin rather than plate. Getting well now? Convergent plate margin is better term, divergent plate margin is better term, conservative plate margin is better term. Getting well now? Now see, it is clear that actually plate tectonic theory is, you must keep in mind that as far as the question of plate tectonic theory is concerned, so plate tectonic theory is concerned. So plate tectonic theory is based on three basic assumptions. Plate tectonic theory is based on three basic assumptions. One is drift hypothesis. Drift theory, right, is the basis of plate tectonic theory. Getting well? Second is paleomagnetism. P-A-L-E-O, magnetism. M-A-G-N-E-T-I-S-M. Paleomagnetism is the second basis of the theory. Okay? One is drift hypothesis, second is paleomagnetism, and third one is seafloor spreading. Seafloor spreading theory. Okay? So you see, plate tectonic theory was propounded by Taylor and later improved by Wegener. Getting well now? Actually, paleomagnetism, this concept was developed by Wine, Matthew and Mason, and H. Hess propounded the theory of seafloor spreading. It is clear now? The seafloor spreading theory was propounded by H. Hess. Getting well? Actually, drift theory was propounded by Taylor but later improved by Wegener. Paleomagnetism was propounded by, this concept was developed by Wine, Matthew and Mason, okay? And seafloor spreading theory was propounded by H. Hess. So all the three constitute the basis of plate tectonic theory. It means, you see, plate tectonic theory is further extension of drift hypothesis. Getting well? It is itself based on the drift hypothesis. Getting well? Right? And it is considered more advanced as compared to that of continental drift theory because actually it is based on the concept of paleomagnetism. Okay? Paleomagnetism is considered effective hypothesis which even explain the movement of the pole, which was referred by Wegener as wandering of pole. Getting well now? And paleomagnetism scientifically explain the fragmentation of Pangea after Carboniferous period. Paleomagnetism is applied to explain the fact that prior to Carboniferous period, the entire landmass were united and afterward it got fragmented. What is the basic concept of paleomagnetism? It is clear now? Okay. And third one is the seafloor spreading. The seafloor spreading theory was propounded by H. Hess. H. Hess propounded the seafloor spreading theory. Okay. So we have three theories, particularly one is drift hypothesis, second is paleomagnetism, and third one is sea floor spreading theory. Getting well? Now see, as far as the question of plate tectonic theory is concerned, I said that plate tectonic theory, basic objective of plate tectonic theory is to explain the relative movement of the plate, not individual movement. How one plate is moving with respect to another plate. This is referred to as relative movement. Getting well? So plate tectonic theory explains the relative movement of the plate. Okay? Right? Now the question is, you see, what factor, which force is responsible to cause movement of the plate? It is very important aspect. Getting well? Because you see, Wegener propounded continental drift theory and he used three forces, applied three forces which were held responsible for fragmentation of Pangea. The forces were right force of buoyancy, differential gravitational pull and tidal force. Getting well? And actually continental drift theory was also criticized on the ground of inadequacy of forces. So that's why particularly plate tectonic theory is based on more effecting an advanced particularly hypothesis and explaining the movement of the earth interior. Getting well now? And plate tectonic theory is based on the Arthur Holmes thermal convective current theory. Okay? Thermal convective current theory. Arthur Holmes propounded mounted building theory of thermal convective current theory, na? Right? And he said that it is due to the actually, you see, what is the basic, it is clear now? What are the basis of the plate tectonic theory? There are three bases. One is drift hypothesis. Second is particularly, you see, paleomagnetism. And third one is particularly sea floor spreading theory. Getting well? Now see, as far as the question of movement of the plate is concerned, so movement of the plate, according to plate tectonic theory, the upper part of plate is made up of lithosphere. Actually, lithosphere, right? And it float over the liquid known as asthenosphere. Getting well now? The upper part of the plate is made up of lithosphere and it float over the liquid known as asthenosphere. What is the basic difference between the two? It is clear now? The upper crustal part is lithosphere and it float over the liquid known as asthenosphere. Getting well now? Right? Asthenosphere. So this is the basic difference, because you see, continental drift theory, according to continental drift theory, the upper part of plate is made up of Sial and it float over Sima. But this is not so in case of plate tectonic theory. In plate tectonic theory, the upper part of the plate was considered to be made up of lithosphere and it float over asthenosphere. This is the basic assumption of the theory. Getting well now? Now see, as far as the question of movement of the plate is concerned, so you see, Arthur Holmes said that due to the differences in the concentration of radioactive element, temperature difference develop in the interior part, that is in lithospheric area, in asthenosphere, right, which exists in the liquid form. And you know that in the liquid, the best mechanism of the transmission of energy is the convectional process. So he said that due to the differences in temperature in the lower part, that is asthenosphere, this asthenosphere was not used by Arthur Holmes. Arthur Holmes considered the upper part of the earth as a stratum and the lower part which exists in the solid form, and the lower part he used the term substratum which exists in the liquid form. Okay? So according to Arthur Holmes, in the lower part there exists particularly flow of thermal convective current in the interior part of the earth. Getting well now? Flow of energy in the interior part of the earth. Getting well now? Right? So such type of particularly, you see, you know that convection always proceeds in the cyclic way now. So due to the flow of this thermal convective current in the substratum, okay, movement of the plate occur. Okay, movement of the upper crustal part, right, occur. It is clear now? You see, there are two particular examples here. This is ascending column of thermal convective current, okay, and this is descending column of thermal convective current, okay. So we have two examples. I am giving two examples. One is the ascending column of thermal convective current, and it means particularly current is moving, is flowing in upward direction, okay? And this is descending column. Again, this is descending column of thermal convective current, okay? The area where ascending column of thermal convective current operate, okay, it causes the plate to move in opposite direction, getting well now, right? To move in opposite direction, and the plate margin is of divergent nature. On the other hand, where descending column of thermal convective current occur, then it causes the plate to move towards each other, and it makes the plate convergent, okay? So it is clear that it is based on the flow of the thermal convective current which causes the plate to become convergent or divergent, okay? The movement of the plate was explained by Euler's theory, which is important theory of physics. According to this theory, the plate move with respect to the minor circle, right? है ना? Minor circle, it is clear na? Right? And on this basis, he explained, particularly scientists explained the convergent and divergent of the plate and also conservative plate. Getting well now? So broadly, it is not essential. Simply, you can understand that the downward descending column of thermal convective current causes the plate to converge. Upward descending column of thermal convective current causes the plate to diverge. Getting well now? So what is the meaning of convergent plate? What is the meaning of divergent plate? It is almost clear. Getting well now? Now see, what is convergent plate, what is divergent plate, what factors are responsible for movement of the plate, got it now? Right? Actually, when two plates move in opposite direction, it is referred to as divergent. If particular in the same direction, it is referred to as convergent. You cannot refer any individual plate perfectly as convergent or divergent, because one margin of the plate may be divergent, but other margin of the same plate may be convergent. As for example, you see the western margin of African plate is divergent with respect to American plate, whereas north eastern margin of African plate is convergent with the Eurasian plate. Getting well now, right? So actually, this is the way. Similarly, particularly when you will go through American plate, you will find that eastern margin of American plate is divergent with respect to African plate, but western margin of American plate is convergent with the Pacific plate. Getting well now? Now see, what is plate tectonic theory? It is, I think that you are understanding the matter in effective way. Getting well? Now see, as far as the question of convergent plate is concerned, okay? Convergent plate is concerned. So convergent plate is concerned. So you see, this is one plate and this is another plate. No? When two plates move in opposite direction, it is referred to as convergent plate. And I have already said that the downward descending column of thermal convective current causes the plate to move in each other direction. Okay, causes the plate to move in each other direction. Getting well now? You simply understand. Then later I will improve it. Suppose it is clear that downward descending column of thermal convective current causes the plate to particularly to move in each other direction and makes the plate convergent. Okay, and you also know that convergent plate is also referred to as destructive plate. When the two plates, I am particularly simplifying then I will improve it. Okay, when two plates will converge, one plate is subducted in downward direction and second plate override it. Getting well? These are the two plates. Getting well? Okay. When this plate, suppose this is A and this is B, A and B particular are the two plates. They are the example of convergent plate. When two plates will converge, one plate will be subducted in downward direction. Getting well now? And when the plate will subduct in downward direction, you know that Benioff was the important geographer. Benioff, who said that the temperature of the zone located between 70 to 300 kilometer in the interior part, 300 to 700 kilometer in the interior part of the earth is so high that it causes the melting of the rock, and this is referred to as Benioff zone. Okay, this part of the earth interior is referred to as Benioff zone. Getting well? So actually you see when the subducting plate will enter in the Benioff zone, okay, due to high temperature condition, it will convert into magma. Magma formation will occur. Getting well? Right? Molten rock material in the interior part of the earth is referred to as magma. Magma. Getting well? And when the molten rock material comes outside the earth, it is referred to as lava. So normally it is said, in most of the book it is given that the basic difference between molten rock material is magma when it exists in the interior part of the earth. But when it comes outside, it is referred to as lava. But there is a fundamental difference. When molten rock material remain in the interior part of the earth, it contains volatile material. Okay? But when it comes outside, the volatile material, when exposed directly to the atmosphere, gets evaporated. It is clear now? So magma contains volatile material, but volatile material are missing in the lava. This is the basic constitutional difference between magma and that of lava. Getting well? Now see, when magma will be formed due to the melting of the rock, okay, the volume as well as surface area of rock is less as compared to that of magma. Getting well now? The surface area and volume of magma is large as compared to that of rock now. Getting well now? So in this case you see, larger, according to the law of surface tension, larger will be the surface area. Getting well now? More will be the energy, and higher energy state impart unstability to the system. Getting well now? So that's why when magma is produced in the interior part of the earth, it makes the area unstable. Getting well? Makes the area unstable, and since its volume increases, it will push the overriding part in upward direction. Okay? Normally, you can understand in simple way that if magma will push the overlying part in upward direction, then upper part will develop in the form of fold mountain. Getting well? But here you must keep in mind one important point. Dana stated that as a result of convergence of the plate, fold mountain are formed mainly when, okay, fold mountain is formed mainly when, particularly if there exists geosyncline between the two particularly convergent plate margin. Getting well? Now, what is the meaning of geosyncline? So actually you know that there occurs deposition at the bed of the ocean, okay, and consequently the sedimentary rock is formed. When thickness of the sedimentary rock becomes more, then it starts subducting in downward direction, then it is referred to as geosyncline. What is the meaning of geosyncline? It is clear now? And a geosyncline is the sedimentary rock, thickly bedded sedimentary rock which starts subducting due to its severe weight. It is defined as, it is characterized by deposition, compactation and subsidence. Getting well now? Suppose particularly this is one plate and this is another plate. Getting well now? In this area there is a oceanic area. So here particularly there will be deposition of the sediment due to continuous deposition of the sediment. Okay, sedimentary rock is formed, and when its thickness will be more, then it will convert into geosyncline. Okay, and you see, since it's due to its weight, geosyncline subduct, that's why convergent forces will get accelerated, and it will cause the folding of this part. So you see it in more clear way that suppose particularly this is the one plate and this is another plate. One is convergent and second is particularly, you see, this is one plate and there is a geosyncline. This is another plate and this is actually they are convergent in character, and there exists a geosyncline between the two plates. Okay, so convergence of the plate will cause, will exert orogenic compressive force here, will create orogenic compressive force. Getting well? And you know that orogenic compressive force causes folding of the part. Okay, so when the two plates will move, you understand the fact. Actually, one plate will subduct in downward direction and geosyncline will get folded. Getting well? Geosyncline will get folded. Okay, and another plate is located here. These are the two plates. This is A and this is B. Particularly, these are the two two plate, convergent plate and geosyncline was initially existing between the two plate, and due to originating compressive force, the geosyncline folded. So this is actually upper part is referred to as anticline and subducted part is referred to as syncline. So when this plate entered in the interior part of the earth, due to high temperature condition, melting of the rock occurred, and due to melting particularly you see its volume increased now, and it pushed the overlying area in upward direction. Gradually the area will uplift and will take the form of fold mountain. Getting well now? So one important aspect, when there will be convergence of the plate and in between the two plates there will be geosyncline, then this geosyncline will get folded to produce fold mountain. As for example, you see Eurasian plate. Eurasian plate, this suppose particularly this is Eurasian plate and this is Indian Ocean, this is African plate and this is particularly Indian Ocean plate, and previously in the intervening area there was a Tethys Sea. This is Eurasian plate, Eurasian, this is African plate and this is Indian Ocean plate. It is clear now? So you see African plate is moving in this direction, Eurasian plate is moving in this direction, and Indian Ocean plate is moving in this direction. Clear? It is clear that Eurasian and African plate are the example of convergent plate. Again, Eurasian plate and Indian Ocean plate is the example of convergent plate now, and the intervening zone there was a Tethys Sea. So due to convergence of the two plates, originally compressive force operated here and it caused the folding of this part. In this part, right, alpine mountain came into origin. Getting well now? And due to folding of this part of geosyncline, Himalaya came into origin. Getting well now? So actually how fold mountains are created, I am simplifying the fact. Actually you see Himalaya, the area where Himalaya exists right now was the zone of Tethys Sea. Okay, I said that there are actually how geosyncline is formed. So due to compactation, due to deposition compactation, okay, deposition compactation and subsidence. Subsidence is the result due to overweight na. So actually this process formation of geosyncline is referred to as lithogenesis. Getting well now? What is the meaning of lithogenesis? Lithogenesis is the process of the formation of geosyncline. This is the first stage for the origin and development of the tertiary fold mountain. Second is the folding of geosyncline into anticline and syncline. This is referred to orogenesis. Getting well now? And you see when this rock will melt to form magma, okay, to form magma, then it will push the overlying part in upward direction, and hence the height of mountain will gradually increase. This is referred to as glyptogenesis. Getting well now? Glyptogenesis is the process of gradual upliftment in the height of the mountain. So there are three stages of mountain building. One is lithogenesis, second is orogenesis, and third one is glyptogenesis. Getting well now? As for example, the height of Himalaya is gradually increasing with an average rate of 6 centimeters per year. So it means Himalaya exists in the glyptogenetic stage. What is the meaning of this aspect? It is clear now? Again you see, okay, again you see, suppose it is clear that this is one plate and this is another plate, and in between the two there was geosyncline, and later particularly when subduction occurred, this plate entered in the interior part of the earth. This area got folded, and this is another part of the rock. Okay. Now see, when the rock will melt to form magma, it will impart instability to the system. It will impart instability to the system, and it will push the overlying part in upward direction. It is clear now? It will push the overlying part in upward direction. Consequently, the height will increase on one hand now. And you see, this magma will impart instability because its surface area as well as volume is more as compared to that of the rock. So, how the area can attain stability? You see, the area can attain stability if the magma will shift from this area. One particularly, suppose particularly this magma shifted toward the core, then it can attain stability, but this is not possible because liquid always flow from high pressure zone to low pressure zone. Getting well now? So the only option for the magma is anyhow to come out of the surface. It is clear now. You see one important point: every fold mountain in the interior part, do contain magma chamber, and magma try to come outside the surface. Getting well now? That's why it causes tremor or vibration, and hence earthquake occur. So that is the reason why Rockies, Andes, Alps and Himalaya are seismically active zone. Getting well now? Because they are the example of tertiary fold mountain, and they contain magma chamber in the interior part of the earth. They contain magma chamber in the interior part of the earth. What is the basic concept? It is clear now? Okay. Actually, you see the magma will try to come out the surface, and first it will have collision with the crustal part, and then earthquake will occur. Getting well now? And if the magma is capable to fragment the crust and come outside the earth's surface, then volcanic eruption will start. Okay? You see, there is no path for the magma to come outside now. So that's why you see this type of volcanic eruption is referred to as explosive type, because it causes explosion of the crust. What is the meaning of explosive type of volcanic eruption? It is clear now? It is referred to as explosive type of volcanic eruption because it causes the explosion of the crust and come outside the earth's surface. Getting well? So actually one important point, the convergence of the plate may cause the origin of the fold mountain. You know that. And Dana said that if geosyncline is located there, then particularly folding will occur and fold mountain will be created. Second aspect, it will cause earthquake, or it may cause particularly volcanic eruption, and the type of volcanic eruption is either referred to as explosive type, and you know that explosive type of volcanic eruption is also known as central eruption type. Okay, so you must keep in mind one important point. As far as the question of volcanic eruption due to the convergence of the plate is concerned, it depends on two factors. One factor is if the volume of magma is exceptionally large, or second, if thickness of the rock is low. Okay, as for example, I am giving the example. You see, this is Eurasian plate. Okay, this is African plate, and this is Indian Australian plate. And prior to the origin of Himalaya, right, actually, or Alpine, Tethys Sea was existing here. You see, the eastern part of Tethys Sea was deep as compared to that of western part, okay, and was more broader. It is clear now? So actually you see, this is moving in this direction and this is moving in this direction. They are the example of convergent plate margin. Again, Indian Australian plate and Eurasian plate is the example of convergent plate margin. So due to convergence plate, orogenic compressive force will operate, and this will converted into alpine mountain. Getting well now? On the other hand, since width and depth of the eastern part of alpine was more, that's why Himalaya, the rock of Himalaya, rock constituting Himalaya is more particularly, and its thickness is more as compared to that of alpine. Since you know that they are the example of convergent plate, so here particularly there exists magma chamber, and also here exists magma chamber in the interior part of the alpine as well as Himalaya. You see, in alpine, since thickness of the rock is less as compared to that of Himalaya, so that's why here magma is capable to come outside the surface, and hence in alpine zone there exist several volcanic eruptions like Etna, Stromboli and Vesuvius. Getting well now? But since the thickness of the rock constituting Himalaya is large, that's why magma is not capable to come outside, right? That's why Himalayan zone experiences only earthquake but not volcanic eruption so far, right? Though, if since the two plates are continuously converging, so that's why maybe in the future that the volume of magma will be much more large and it may cause explosion of the crustal part. Getting well now? So what is the basic theme, particularly difference between that of alpine and Himalayan zone? It is clear now, right? If high alpine zone experiences volcanic eruption as well as earthquake, because you know that every volcanic eruption remains associated with the earthquake, but it is not essential that every earthquake will be associated with the volcanic eruption. Getting well? So in alpine zone, right, or Mediterranean zone, you can say, experiences earthquake as well as volcanic eruption, but so far Himalayan zone not experienced the volcanic eruption, right? Actually, you see, you can apply this theory to explain the earthquake in Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Sikkim, northeastern states, okay, and also particularly you see in recent past, right, Himalayan region or Nepal was experiencing the earthquake frequently. According to some geographer, maybe this may be the pre-sign for incoming volcanic eruption in the future. Getting well now? But actually so far there is no volcanic eruption in this zone, right? Because particularly you see the thickness of rock constituting Himalaya is much more large as compared to that of alpine zone, right? So what is the basic difference between the two? It is clear now? Getting well now? Now see, now the question is, it means particularly convergence of the plate will cause the formation of fold mountain. It may explain the earthquake or volcanic eruption, okay? Again you see, now the question is, when the two plates are moving in towards each other, if this is one plate and this is another plate, if they are moving in each other direction, getting well now? Each other direction. So if the two plates are moving in each other direction, then what will happen, you see, right? Actually, if they are moving, then which plate will subduct in downward direction is an important question, okay? Whether particularly A will subduct or B will subduct, okay? So actually you must keep in mind one important point. The plate having more density will subduct in downward direction. Getting well now? If suppose this is continental plate and this is oceanic plate, okay, this is oceanic plate, B is oceanic plate and A is continental plate. It is clear now? So I said that if there is a convergence of the two plate having different nature, one is acidic and second is basic, then the plate having more density will subduct in downward direction, because you know that oceanic density of oceanic plate is 3 gram per cubic centimeter, okay, whereas the density of continental plate is 2.7 gram per cubic centimeter. Getting well, right? So in case of convergence of the continental and oceanic plate, the oceanic plate will subduct in downward direction. It is clear? But as for example, you see, if American plate is converging with that of Pacific plate, so Pacific plate will be subduct in downward direction. Getting well now? But you see, if there exists convergence of the two plates of the same nature, then there is, if the nature is the same, both continental or both oceanic, then the density will be the same. Na? So in this case, you cannot apply this aspect, okay, right? So you see, in case of convergence of the two plates of the same nature, means they are either continental or oceanic, okay? Suppose particularly if this is one plate which is continental plate and this is also continental plate, it is clear that density is 2.7 gram per cubic centimeter and its density is also 2.7 gram per cubic centimeter. Then on the basis of density difference, you cannot say that this individual plate will subduct or this will not subduct. Getting well now? So in case of convergence of the two plates, right, their relative velocity is the decisive factor, okay? Suppose its average velocity is 5 centimeter per year and its average velocity is 2 centimeter per year and both are convergent plates, both are converging, okay? If the two plates of the same nature are converging and the plate having more velocity is referred to as hinterland, and the plate having less velocity is referred to as foreland. Okay, here you see this one is the continental plate. This is X and this is Y. So X is continental plate, its density is 2.7, but its velocity is 5 centimeter per year. Y is continental plate, right? Its density is 2.7, but its velocity is 2 centimeter per year. So when two plates will converge, if one is having more velocity as compared to that of another, in this case, the plate having more velocity is referred to as hinterland, and the plate having less velocity is referred to as foreland. Then hinterland will subduct. Okay, this will subduct in downward direction. Getting well now, right? When, as for example, you see the actually Eurasian plate and Indian Austral plate are the example of convergence of the two plates of the same nature, because Eurasian plate, the part which is converging with Indian plate, actually the part of Indian National plate which is converging with African plate is continental in character. But since the velocity of Indian National plate was more as compared to that of Eurasian plate, that's why Indian National plate subducted in downward direction. Similarly, since velocity of African plate was more as compared to that of Eurasian plate, that's why in this case also particularly you see African plate subducted in downward direction. Here particularly Indian Austral plate subducted in downward direction, because this is Indian Australian plate and this is African plate. Getting well now, right? So it is clear that if the two plates which are converging are having the different density, then the plate having more density will subduct in downward direction. But if they are of the same nature, both are continental and both are oceanic, then velocity factor play decisive role. The plate which will have more velocity will subduct in downward direction. It is clear now? So what is the basic difference between what type of phenomena will occur? What phenomena you can explain on the basis of convergent plate? It is clear so far. One is, first factor is, you see, first is fold mountain, right? Second is earthquake. Third phenomena is volcanic eruption, and this volcanic eruption is also referred to central eruption type or explosive type of volcanic eruption. Again, you see, when two plates, mostly it is said that, but there are exceptions also. But if two plates will converge and they are of the same nature, oceanic in character, then what happens, you see, right? Actually, in case the two plates, this is oceanic one and this is also oceanic one, they are converging, right? So it is said that one plate will subduct if their velocity is more, and this will also subduct in this way. Consequently, a depression is produced, okay? And this is referred to as oceanic deep or oceanic trench. But the oceanic trench is also the product of convergence of the plate, mostly if the two plates are of oceanic character, and the deepest part of the trench is referred to as deep. As for example, the deepest part of Mariana Trench is the Challenger Deep, okay? And if there will be convergence of the two plates of the oceanic character, if in the waning period, suppose you see, if warping will happen here, warping, okay? Because you know that convergence of the plate also causes convergence of the plate, causes orogenic compressor force, and orogenic compressor force causes folding of the rock, right? If there is anticline and syncline, then it is referred to as folding. But if no anticline and syncline is formed, it is referred to as warping. So due to warping, particularly island arc and festoon can be produced. So it means the convergence of the plate causes you apply the convergence of the plate, that is plate tectonics, to explain fold mountain, it is clear. As for example, Rockies is due to the convergence of American and Pacific plate. Andes is due to the convergence of American and Pacific plate in South America, okay? Alpine is due to the convergence of Eurasian plate and African plate. Himalaya is due to the convergence of Eurasian plate and Indian Austral plate, okay? Second aspect is earthquake. You can explain. Earthquake can be explained on the basis of convergence of the plate. Third is volcanic eruption, right? This volcanic eruption is of explosive type or central eruption type. Getting well now? Fourth phenomena is oceanic trench and or deep formation is occur, okay? And fifth one is particularly island arc and festoon. These are the important phenomena associated with convergence of the plate. Okay, it is almost clear now. The convergence will cause the formation of fold mountain. You can explain the origin of the fold mountain, tertiary fold mountain. Okay, because you see, you must keep in mind, every mountain cannot be explained on the basis of plate tectonic theory. Okay, according to age, we have 4 category of mountain. One is Precambrian mountain, second is Caledonian mountain, third one is Hercynian or Variscan, and fourth one is tertiary mountain. Getting well now? So plate tectonic theory can be applied only to explain the tertiary fold mountain. Okay, you cannot apply the plate tectonic theory to explain the Caledonian mountain or Precambrian mountain, Hercynian or Variscan mountain. Getting well now? Again, you see what is the explanation is clear enough. Now see, second aspect is, I had said that according to relative movement, there are 3 types of plate. One is convergent, so we discussed about convergent. Now, divergent plate, you see, when the 2 plates will move in opposite direction, it is referred to as divergent plate. And you know that I have already explained that ascending column of thermal convective current causes the plate to diverge in opposite direction. So when the plate will diverge, you see, if there exists a rock here, right, divergence of the plate will cause reduction in the pressure of the rock. Okay, when divergence of the plate causes reduction in the over the pressure of the rock. Okay, and according to law of physics, lowering of pressure causes lowering of the melting point. Getting well now? So as a result of this, you see the rock will melt to form magma. Magma formation will occur, and you see along with the divergence of the plate. Okay, along with the divergence of the plate, if plate is diverging, then along with the divergence of the plate, then you see a fissure is created along with the divergence of the plate, and there will be path for the magma. You see, when the 2 plates were converging, then no path was created for the magma to come outside now. But here, due to divergence, there occurred the creation of the fissure now. That is particularly a path for the magma to come outside now. So that's why the magma will come outside. First, it gets solidified at the floor of the ocean and create new oceanic crust. So first phenomena associated with divergence of the plate is the creation of new oceanic crust. Okay, new oceanic crust is formed as a result of divergence of the plate. Second phenomena is, if the magma is coming out, then certainly it will create particularly earthquake, getting well now. Okay, and again particularly volcano. Third phenomena is, since magma is coming out of the surface, so actually ejection of earth material outside is referred to as volcanic eruption. So this is volcanic eruption. Volcanic eruption will also occur. Okay, volcanic eruption will also occur, and this type of volcanic eruption is referred to as fissure type of volcanic eruption, right, or quiet type. Why fissure? Because fissure is created due to the divergence of the plate. So that's why magma not required to conduct explosion comes slowly outside. That's why it is also referred to as fissure type or quiet type of volcanic eruption. Getting well now? And again you see, if the volume of magma is more, okay, then volume of magma will more, then it will come here and it will solidify to form mountain type of feature, ridge type of feature. Okay, so this ridge type of feature is referred to as oceanic ridge. Okay, getting well? Oceanic ridge is is associated with volcanic eruption. Getting well now? As for example, you see African plate, right? This is American plate. This is American plate, okay, and this is African plate. Okay, and this is the area. Right, up to this area there is a African plate, and in this area there is American plate. Both are the example of divergent plate. That's why in the central part of African plate, the central part of this plate margin, this is the example of divergent plate now. So here, due to the solidification of magma, S-shaped ridge is found, which is referred to as mid-Atlantic ridge. Right, mid-Atlantic ridge, it is clear now. Actually, most part of the ridge remain submerged under water, but some part of the ridge is exposed above the water. As for example, Iceland is located on this ridge. Again, you see some part of the ridge extend in the southern part of Greenland in the form of telegraphic plateau. So, what is the basic theme? It is clear, na? Telegraphic plateau is also the product of the divergence of the plate, na? Okay. So, actually, fourth phenomena is basically, you can say, formation of oceanic ridge. Getting well? So, you see, as far as the question of what are the phenomena associated with the divergence of the plate, it is clear now. But the convergent, now you see, convergence of the plate causes the formation of convergence, right? Convergence. First was convergence of the plate. So convergence of plate remain associated with the following phenomena: fold mountain, right? Earthquake, volcanic eruption, okay, again oceanic trench and dip, again particularly you see Iceland Arcane festoon. Getting well? These are the phenomena associated with the convergent of the plate, okay. If the plate is divergent, then it will divergent plate. So divergent plate is also referred to as constructive plate. So actually it is associated with the formation of new oceanic crust. New oceanic crust are created. Again, earthquake happen. Again, particularly fissure type of volcanic eruption or quiet type of volcanic eruption occur, and oceanic ridges are created. So these are the important phenomena associated with the divergence of the plate. And I said that when the two plates laterally move, either in the same direction or in the opposite direction. It is clear, na? Or in the opposite direction. Getting well? If the two plates move in opposite direction or the same direction, it is referred to as conservative plate, and conservative plate remain associated with two important phenomena. One is, right, a formation of transform fault, okay? When the formation of transform fault is mainly associated with the convergent plate margin, okay, or earthquake may happen, okay. So there are three types of particular plate, you know, convergent, divergent, and conservative plate, okay. It is clear now. So what is the impact of the plate getting well, right? I think that the topics is almost clear, okay. Retain the fact. Again, we will meet in the next classes, comparing continental drift theory and plate tectonic theory. Best of luck.